Good morning, all of you, ma. Okay, so today we are going to see the last topic in the fourth unit and the last topic in our CTPST. Okay, by this topic, our entire syllabus will be completed. Okay, so the last topic of this particular unit is nothing but, okay, in the second part, we have seen about problem solving, designing mechanism or techniques, right? In that we have seen brute force algorithm, divide and conquer mechanism. Okay, so today we are going to learn about the greedy method or greedy strategies. In your syllabus it is given as greedy strategies. Okay, so what is mean by greedy method or what is mean by greedy strategies? Okay, and what you are going to do in this one and what are the different kind of algorithms we are going to use in this particular greedy method. Okay, we will be going to learn in today's section. Okay, so greedy method is used for obtaining the optimal solution. Okay, so here this particular greedy method is used for finding the minimum cost of one particular spanning tree. Okay, so before going to the spanning tree, first of all we will know about the tree. Okay, a tree is nothing but what? Where it consists of a number of vertices and edges, right? Sorry, a tree is nothing but where it will be consisting of roots, branches and leaves, right? So, but here, when you are talking about the minimum spanning tree, okay, it is not related to the trees where we will be having roots, branches and leaves. But here we will be talking about a concept known as graph. Okay, so minimum spanning tree will be drawn for a graph. Okay, so a graph will be denoted with G. Okay, and this particular graph will be consisting of n number of vertices and n number of edges. Okay, so all the vertices are represented as V and all the edges were represented as E. Okay, so the vertices are nothing but n number of nodes that you are having. For example, if I have taken A, B, C and D. Okay, so these four are said to be as vertices. V is equals to A, comma, B, comma, C, comma, D. These are the vertices of my particular graph. Edge is nothing but where there is a link between all these particular vertices is said to be as an edge. That means how these two vertices are associated to each other will be specified as an edge. So you can specify E1, E2, E3, E4 like this. Okay, so there exist four edges, or you can also have one particular edge like this. You can specify this one as E5. That means a graph will be consisting of n number of vertices and n number of edges. Okay, so this is said to be as a graph. Okay, and we are having two different kind of graphs, that is directed graph and undirected graph. When you are talking about the directed graph, that we will be specifying the flow, okay, from which vertices to which vertices it is traversing will be specified. That is the direction of traversing a graph will be specified. Okay, so this indicates that the flow of vertices. Okay, so how two different vertices are moving. Either they are moving in the forward direction or they are moving in the backward direction. The visit, how it is visiting will be specified. Thus, visiting will be specified by making use of this particular arrow. When the direction is specified, okay, then it is said to be as a directed graph. Now this graph is said to be as a directed graph. Okay, so undirected graph means a graph. Okay, if I have taken like this, okay, a graph is consisting of three vertices and three edges, but I have not specified any arrows. That means it indicates that it is an undirected graph. Undirected graph means it can travel in both the ways. That means it can visit from A to B or it can also visit from B to A. That it is said to be as an undirected graph. Okay, and the next one we are having is weighted graph. Weighted graph means all these particular edges we will be specifying the cost. Okay, on the edges we will be specifying the cost. Then it is said to be as a weighted graph. For example, if I have given here 10, 20, 30 like this. Okay, then that particular graph is said to be as a weighted graph. Weighted undirected graph. Okay, why means it is not showing any direction. Here it is showing the direction. So if I'm specifying here as some 10, 20, 11, okay, or 12, some 35 like this. That means this particular graph is said to be as weighted directed graph. That means on the edges we are specifying the weights that are nothing but the cost of that particular weight or the distance, okay, of that particular between two different vertices. Okay, so in order to find out a minimum spanning tree, okay, so ఈ కాస్ట్ అనేది ఎందుకు స్పెసిఫై చేస్తాము అని అంటే it should travel from source to destination within short period. Okay, the distance or the cost should be less. Okay, then it is said to be as an shortest path. The traversing will be shortest path distance. Okay, if you are talking about the cost, then we will be specifying that one as minimum cost spanning tree. Okay, so these are used like this. Okay, that means if I want to visit from A to D, okay, I can visit in two directions. That is, first of all, I need to visit from A to B, then B to C, then C to D. That means this direction is specified. Okay, and another way that I can visit from A to D is A to B and B to D directly. Okay, in two different ways I can visit this. So visit this particular vertices D. Okay, so in order to visit that one, I should find the shortest path. Okay, so first I am having A to B visited 10. Okay, B to C visited, I am getting that weight as 20, and C to D I am getting 11. So totally, what is the distance? 41. Okay, the distance from A to B, whenever it is visiting from A to B, B to C, and C to D means the distance is 41. Okay, and another way I can A to B is nothing but 10 and B to D is nothing but 12. Okay, so that total is 22. So this is the shortest path where I can visit. Okay, so such kind of things will be specifying here. That means we are finding the optimum solution. Okay, the optimum solutions are obtained by making use of this particular greedy algorithm. Okay, in order to find out that particular optimum use of either this particular Kruskal's algorithm or minimum spanning tree. This minimum spanning tree algorithms are used for finding the minimum cost of that particular edges where it can visit from source to destination. Okay, in order to do that one, we will be making use of this particular greedy method. Okay, so this particular greedy method is used for finding the optimum solution. That is the first point, and this is a straightforward mechanism where you can find out the optimum solution. Okay, and here the second thing that you have to keep in mind that this greedy method will be having a set of feasible solutions is generated and optimum solution is selected. Okay, n number of solutions will be generated, but the best one will be selecting. Previously I have told I can visit from A to D in two different ways. Whenever I am visiting from A to B and B to C and D to D, C to D, I am getting the distance as 42. But whenever I am visiting from A to B and B to D, I am getting that total cost as only 22. So which one will be the best one? The shortest path, right? So that's what we will be doing. We will be selecting the optimum solution. That means here we will be getting a set of feasible solutions. A number of feasible solutions we will be getting. Okay, but we will be selecting is only one optimal solution. That is, which is the best one you prefer, that one only will be selected. So that's what it will be consisting. A greedy method will be consisting of a set of feasible solutions will be generated, but an optimum solution is selected. Okay, which one will be the best and which one will be the shortest path of traversing that particular graph? That particular shortest path with minimum cost will be selected. That is about the second point. And third point, you have to keep in mind that no revisiting of already visited nodes. Okay, a node means that means that node is nothing but what? One vertices. If one vertices is visited, again no need to visit that particular vertices again. Okay, that is the second thing. Third one, okay. No revisiting previously generated solutions, already generate అయిన solutions ని మళ్ళీ మనము revisit చేయొద్దు. Okay, and this particular greedy method is an efficient method when compared to the all different algorithms. Okay, so in greedy method we will be having many different kind of algorithms. Snapshot algorithm, we will be having prism algorithm, crucial algorithm, minimum spanning tree, Dijkstra, like that n number of algorithms we are having in order to find out the shortest path by making use of greedy mechanism. But in your syllabus, we are having only one algorithm, that is nothing but Kruskal's algorithm. So today now we are going to learn about the Kruskal's algorithm. Okay, so the best example of this particular greedy method are nothing but two algorithms, that are minimum spanning tree algorithm and Kruskal's algorithm. Okay, so these are the two different examples of greedy algorithms. Okay, that is snapshot problem and minimum spanning tree. Okay, in the minimum spanning tree algorithm, either you can make use of prism algorithm or you can make use of Kruskal's algorithm. Okay, this is about the greedy method. Okay, so now we will take one particular example. Okay, so A, B and C. Okay, this is my particular one graph. My graph is consisting of three different vertices. Okay, so that three different vertices are nothing but A, B and C. Okay, and it is consisting of three different edges, A to B, B to, okay, edges are nothing but what I'll be getting, AB, okay, BC and CA. Okay, so these are the three different edges I'll be having. Okay, a graph is denoted with what? Vertices V and edge. Okay, so vertices and edges has to be specified. For this graph, okay, what are the vertices I'm having? G is equals to A, B, C. And what are the edges I'm having? AB, BC and CA. Okay, this is my graph G. Okay, so for this particular graph, I need to construct a spanning tree. Okay, so the spanning tree will be constructed, okay, with, okay, a tree ichina kani a spanning tree ni construct cheyali anante we will be following this particular problem, okay, this particular formula, that is n to the power of n minus 2. That means how many number of spanning trees I can generate for one particular graph. Okay, this is my particular graph. For this particular graph, I will be constructing n to the power of n minus 2 spanning trees. Okay, so for example, n is nothing but how many vertices I am having. Okay, 1, 2, 3. I am having three different vertices. So n value will be 3. So 3 to the power of 3 minus 2. Okay, 3 to the power of 3 minus 2. So 3 to the power of 3 minus 2 means I'll be getting that one as 3 to the power of 1. That is nothing but 3. That means I will be getting three different spanning trees. Okay, how many spanning trees I'll be getting? In order to find the spanning trees, I need to use the formula known as n to the power of n minus 2. So n to the power of n minus 2 means I'll be getting that one as 3 to the power of 3 minus 2, that is nothing but 3 to the power of 3 minus 2 means 3 to the power of 1. 3 to the power of 1 is nothing but 3. Okay, so that means I'll be getting three different graphs for this particular three different spanning trees for this particular graph. So what are the three different spanning trees I'll be getting are, I should visit all the three different vertices. Okay, so in order to span that one, okay, ikkada em vachindi manaki 3 to the power of 3 minus 2, that is 3 to the power of 1, that is equals to 3. That means I should get three different spanning trees. Okay, this is about the graph. Okay, graph consisting of B, E. Okay, first of all, one graph I'll be getting is A, B, C. First, I'll be visiting from A to B and B to C. This is one graph, and another graph I'll be getting that one as like this. I can visit from B to A and A to C. Okay, that means all the edges, that means all the vertices should be visited. Okay, So these are the two different graphs I'm getting. Okay, and I should get how many graphs? 3 graphs. So another graph I'll be getting as ABC. One second, ma. A, B, C. Okay. So I can visit A, then B, and then I can visit C. Okay. Then after that I'll be visiting A. Okay. B, C. Okay. This is the second graph. Okay. And then I'll be visiting directly A to B and A to C. All the three different vertices has been visited. Okay, this is my graph 1. This is graph 2. And this is graph 3. Okay, initially, okay, my first graph is consisting of three different vertices A, B and C and with three different edges. I should get how many trees? 3 trees. I should construct three different spanning trees. Why means I am having 3 edges. So I will be getting 3 to the power of, what is the formula I am using? N to the power of n minus 2. So n is nothing but 3. Okay. I am having 3 vertices. So that's what n will be 3. So 3 to the power of 3 minus 2, that is nothing but 3 to the power of 1, that is equal to 3. That means I should construct 3 different spanning trees. So that's what I'm having 3 different vertices with 3 different edges. So I should visit from A to C in one direction. First I'll be visiting from A to B and then B to C. So all 3 different vertices has been visited. That is the first graph. Then the second graph where you can visit all these particular vertices means first I can visit from A to C and then C to A. A means C key, C means B key. Okay, so that's what A to C and C to B. That is the second graph. Directly I can visit third graph. I'll be getting that one as A to B and A to C. So I'll be getting A to B and A to C. Okay, so these are the 3 different graphs I can generate for this particular spanning tree. Okay, this is the first graph. Okay, and this one is the second graph, and this one is the third graph for the first basic graph G. Okay, this is about the construction of the spanning tree. Okay, we are not telling that one as a minimum spanning tree. Why this? We have not given any cost on this particular edges. If you have given, so you can tell them as a cost or weight or distance. Okay na? Source నుంచి destination కి మీరు travel చేయాలి అని అంటే distance అంటారు. Okay na? Shortest path distance అంటారు. Okay na? Weights. If you want to calculate how much it weighs, then we will be using weights. Okay, spanning tree అన్నమాట we will be specifying the cost. Okay, so what are the different kind of digits that you are specifying on the edges will be specified as a cost. So here we have not specified any cost. Only we have taken one particular graph, and for that particular graph we have generated n number of spanning trees. Okay, this is about the construction of spanning tree. Okay, next coming to the second one. Okay, we need to find out the cost minimum spanning tree. So minimum spanning tree means on this particular vertices I will be specifying the edges. Okay, so for example if I have taken 10, 20, 30. Okay, so 10, 20, 30. I need to visit from A to C. Okay, my graph is consisting of A, B and C. I need to visit my graph with A to C. So in order to visit my graph from A to C, I will be getting 3 different spanning trees. Okay, in the 3 different spanning trees, okay, the cost will be varied. Okay, if I am traveling from A to B and B to C, then I will be getting 10, 30. That means the cost will be what? Cost will be 40. Okay, and if I am traveling from A to C and C to B, okay, so what I will be getting? 20 plus 30, I will be getting 50. Okay, and if I am traveling from A to B and B to C, then I will be getting 30, right? So here in which way you need to travel should be specified. Okay, the minimum spanning tree should be constructed by selecting the smallest distance that you need to travel from source to destination. Okay, so if you are having n number of vertices, then the edges will be, okay, the edges will be n minus 1. Okay, the edges will be n minus 1 edges. So here I am having 3 vertices, then I should get only 2 edges. Okay, that 2 edges, if I want to visit from A to C, directly I can visit from A to C in 2 different ways. Directly from A to C, the cost is nothing but what? 20. Okay, and second thing, I can visit from A to C in another direction as A to B and then A to C. A to B and then B to C. So what is the cost I am getting? 10 and 30. So here it is 40. So that's what, instead of going for this one, I'll be directly visiting from A to C by making use of the shortest path, that is nothing but directly A to C with the total cost 20. This is about the finding the minimum spanning tree. Okay. Next, coming to the greedy method. In the greedy method, we are talking about the Prism's algorithm and Kruskal's algorithm. So, in the Prism's algorithm and Kruskal's algorithm, okay, what we will be doing means, okay, what we will be doing means, first, we will be finding the shortest path. Okay, na? So, first thing cheyali anante, for example, I have taken this particular graph, okay, consisting of 7 nodes. Okay, 7 vertices. Okay, 1, 2, 3, 4, 5, 6, and 7. Okay, I am having 7 vertices with n number of edges. How many edges I am having? 1, 2, 3, 4, 5, 6, 7, 8, 9 edges I am having. Okay, for this graph I am having 7 vertices and 9 edges. So, whenever I am having 9 edges, the condition is that when you are having the vertices as n, the edges you should get as n minus 1. So, if I am having 7 vertices, then I should get 6 edges. So, if 6 edges anadi manam ela calculate chestamu anisante, for this particular graph you have given the cost as well as the vertices. Okay, so first we will go with the Prism's algorithm. So Prism's algorithm ఏం చేస్తుంది అని అంటే ఫస్ట్ వర్టిసెస్ ని తీసుకొని దానికి adjacent vertices ని ఫైండ్ అవుట్ చేస్తుంది. Adjacent vertices అంటే ఫస్ట్ adjacent vertices I am having is 6 and 2. Okay, so 6 and 2 is 6 and 2 lo which is the shortest path it will be checking. Okay, so 6 నుంచి 2 1 నుంచి 2 ki I am having that particular cost as 25, but 1 to 6 I am having that cost as 10. So that's what, first it will be moving from 1 to 6. Okay, 1 నుంచి vertices 6 ki move అవుతుంది. And what is the cost I am having? 10. Okay, and next for 6 it will be finding the adjacent vertices. For 6 I am having 2 different adjacent vertices, that is 1 and 5. Sorry, ma. Okay, so for this vertices 6, Okay, we are having two different adjacent vertices, 1 and 5. So 1 is already visited. So that means we won't be considering that one. But we will be considering the vertices. It will be visiting the vertices 5 with the cost 23. Okay, so next graph it will be taking as 25. Okay, next. After coming to fifth vertices, it will be finding what are the different kind of adjacent vertices it is having. Okay, what are the different kind of adjacent vertices it is having? 5, 4, 6 and 7. Okay, so 4, 6 and 7. In this, it will be finding the shortest path. Okay, 6 is already visited, so either it should visit to the 4 or 7. Okay, so 4 is having the cost as 20 and 7 is having the cost 22. Okay, so instead of going with the highest cost, we will be going for the minimum cost. Okay, the minimum cost is nothing but what? 20, right? So that's what it will be visiting the vertices 4 with the cost 20. Okay, then after that it will be finding the adjacent vertices of 4. What are the adjacent vertices of 4? We are having 3, 7 and 5. Okay, so already 5 is visited, so that's what it won't be considering this one. So it will be visiting either to 3 or 7. So the 3 weight is having is 11. Okay, and for 7 we are having the weight is 17. So it will be finding for the shortest. Okay, the minimum cost we are having is 11 on the vertices on the edge from 4 to 3. So that's what it will be visiting the vertices 3 with cost 11. Okay, then it will be finding for the adjacent vertices of 3. Okay, the 3 is having only two different, not only one, it is having two different adjacent vertices, that is 2 and 4. This 4 is already visited. So that's what it will be directly visiting to the vertices 2. Okay, what is the cost of 2 we are getting? That is 14. So it will be visiting the vertex 2. So the cost will be 14. Okay, and it will be finding for the adjacent vertices of 2, that is 1, 7 and 3. So 1 is already visited, okay, and 7 is already, 3 is already visited. So then we will be directly moving to the vertices 7. And what is the cost of 7? We are having 12. So it will be directly visiting to the vertices 7 with the cost 12. Okay, this is about the finding the minimum spanning tree by making use of Prism's algorithm. So what will be the cost? The cost will be 10 plus 25, 35, 35 plus 20, 55, 55 plus 11, 66, 66 plus 14, 80, 80 plus 12, 92. So 92 is the minimum cost for finding the minimum cost of spanning tree by making use of prism. Okay, so E graph is a direct reference, right? So, but we will be getting n number of graphs. It's a direct the graph we draw to you. Okay, so first what we will be doing? First we will be visiting from 1 to 6. Okay, so we will be getting 10. Okay, so all the different vertices will be specified as it is. Okay, like this. Okay, then after that, second where we have visited, this is about the graph. Okay, graph 1. Okay, G1. Okay, with the cost equals to 10. Okay, second graph you have to construct. So second graph we will be getting that one as 1 to 6 with 10, then to 5. 5 వచ్చినప్పుడు మన ఎంత ఉంది 25 cost కదా. So we will be representing 25, then 4 as it is. Okay, then 3, then 2 and 7. Okay, this is about the graph 3. Okay, with cost 10 plus 25, that is 35. Okay, next second graph we will be constructing. Okay, so next graph we will be getting that one as 1, 6, 5. Okay, so from 5 we are directly visiting to 4, 11, 25, 10. Then 3 will be kept as it is, 2 will be kept as it is, and 7 will be kept as it is. This is about the graph 4. Okay. In this graph 4, we are having cost as how much we will be getting? 35 plus 11, 46. Okay, this is about the graph 3. Next graph you need to calculate. Okay, this is the first graph, second graph, third graph. Okay, then we will be constructing the fourth graph. I am erasing this one mark. Okay, so fourth graph we will be getting as we are visiting from 3 to 4 to 3. So we will be getting 1 third graph. Okay, now fourth graph 1 to 6. Next 1 to 5, 1 to 4, and 4 to 3. 25, 11. Okay, and 3 to 4. What we are having the cost is. Sorry, here we are having the cost 20. Okay, and here 11. So 45, 55. We will be getting the cost here as 55. Okay, so the cost here will be getting as 55 plus 11. So we will be getting 66. Okay, in the same way, next we need to visit either to the node 2 or 7. Okay, so whenever we are visiting from here to node 2 or 7 means directly we are visiting to the node 2. Okay, so next graph we will be getting that one as 1 to 6, 6 to 5, 5 to 4, 5 to 3, and 3 to 2. Then we will be getting 7 as it is. So 10, 25, 20, 11, and 14. So what will be the cost here? Cost is equal to 66 plus 14. Okay, 66 plus 14 means what you will be getting? 80. So cost will be 80. Okay, so next graph ni draw cheyali. Appu next graph em chestaru meeru? Either I have to visit from node 1 or 7. So node 1 is already completed, right? So directly node 1 will be already visited with 6. Okay, so 25 and 12. The minimum cost we are having is 12 for node 7. So that's what we will be drawing the last graph, that is 1 to 6, 6 to 5, 5 to 4, okay, 4 to 3, 3 to 2, and 2 to 7. Okay, so I'll be getting cost as 10, 25, 20, 11, 14, and 12. Okay, 80 plus 12. So 80 plus 12 is nothing but what will be the cost? 80 plus 12 is equal to 92. So finally we got the cost 92. Okay, this is about the Prism's algorithm. So Prism's algorithm em chestundi anante cost evaithe untayo annitni first highest నుంచి lowest వరకు తీసుకోవాలి. దాని తర్వాత ఏం చేయాలి? You need to take all the vertices. If you are having n vertices, you need to get n minus 1 edges. So 7 vertices ఉన్నాయి కాబట్టి 6 edges కావాలి. 1, 2, 3, 4, 5, 6. So 6. For the tree, previously we got 7 vertices with how many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 edges ఉన్నాయి. But for that 9 edges, by making use of Prism's algorithm, we are calculating the minimum spanning tree with n number of vertices. If you are having n number of vertices, then you will be getting n minus 1 edges with minimum cost. This is about the Prism's algorithm. Any doubts in this Prism's algorithm? Yes, ma'am, whether you all are here or not.
Yes, ma'am.
Okay, next we will go for the Kruskal's algorithm. Okay, for the same graph, we will be finding the Kruskal's algorithm. So Kruskal's algorithm is also used for finding the minimum spanning tree, minimum cost of that particular tree. But there is no condition that it should visit exactly their adjacent vertices. Prism's algorithm lo em chestunnamu compulsory cost ని ఫైండ్ అవుట్ చేయాలి అంటే దాని అడ్జసెంట్ వర్టిసెస్ ని చూసుకొని ఆ అడ్జసెంట్ వర్టిసెస్ లో ఏదైతే మినిమం గా ఉంటుందో ఆ మినిమం కాస్ట్ ని తీసుకొని ఆ పర్టికులర్ గ్రాఫ్ ని కన్స్ట్రక్ట్ చేయాలి. ఓకేనా? బట్ coming to the Kruskal's algorithm, there is no condition that we have to specify exactly that particular vertices should consist of the adjacent vertices. అలా ఏం లేదు. మీరు తీసుకున్న గ్రాఫ్ మొత్తంలో ఓకే ఏదైతే మినిమం కాస్ట్ ఉందో you need to take that minimum cost vertices and edges. Okay, so this particular graph lo, what is the minimum cost I am having? I am having the cost 25, 10, 23, 20, 22, 17, 11, 12 and 14. Which is the minimum cost I am having in this particular graph?
10.
10. So that's what we will be taking. We will be taking the vertices 1 and 6 and this particular edge. Okay, so first I'll be drawing a graph. Okay, with 1, 6 notes అనేది as it is గా స్పెసిఫై చేయాలి. మీ గ్రాఫ్ కి ఏ నోట్స్ తీసుకున్నామో ఆ నోట్స్ ని అన్నిటిని స్పెసిఫై చేయాలి. 4, 3, 2 and 7. Okay, this is the graph. For this graph, first I'll be finding the minimum cost. So minimum cost అనేది ఏంటి? 10. Okay, so the cost, minimum cost is okay, cost is equal to 10 for this particular graph. Okay, this is the first graph. Then second graph you need to find. Next minimum cost you need to find in this particular graph. 10 tarvata minimum cost ekkudundi 11 and that particular edge is existing between which nodes? 3 and 4. Okay, so you have to, yes, you need to specify this one. Okay, so we'll be drawing the next graph as 1, 6, okay, 5, 4, 3, 2 and 7. Okay, so 10. Then next we are having 3 to 4, 11. So what is the cost I am taking here? Cost is equal to 21. 10 plus 11. 10 plus 11 means 21. So 10 and 11 are completed. Next I need to search for the next minimum cost. The next minimum cost I am having is 12. That minimum cost is existing between 2 and 7. So I need to draw a graph between, I need to draw a edge between 2 and 7. So I need to draw the next graph. 4, 3, 2, 7. So 10, 11 and 2 to 7 is 12. Okay, so now I'll be getting the cost as cost is equal to 10 of 21. 21 plus 12. 21 plus 12 means I'll be getting the cost as 33. Okay, so 12 అయిపోయింది. 12 అయిపోయిన తర్వాత next minimum cost I'm having is what? 14. Okay, so I'll be drawing the edge between 2 and 3 with the minimum next cost 14. Okay, so 1, 6, 5, 4, 3, 2, 7. So 10 has finished, 11 finished, 12 finished. Okay, next cost I am having is 2 to 4, 2 to 3, 14. So I'll be drawing the edge here 14. Okay, this is in Kruskal's algorithm. Okay, so next third algorithm. In Kruskal's algorithm, we will be following this method. So what will be the cost for this graph? 33 plus 14. That is nothing but what? 47. Okay, so after 14, what is the next minimum cost I am having? The next minimum cost I am having is 20. That 20 is existing an edge between 5 and 4. So I need to draw that particular graph. 1, 2, 3, 4, 5, 6, 7. So 10, 11, 12, 14. Okay, and the next minimum cost I am having is between 4 and 5, that is 20. So the cost will be 47 plus 20. I'll be getting that one at 67. That is the next graph. Okay, so after that, after visiting 20, what is the minimum cost I am having? 22. Okay, so 22 is existing between what? Between 7 and 5. Okay, so next minimum cost what I am having? So the next minimum cost I am having is 22. Okay, so whenever I am specifying 22 here, okay, then the graph won't be repeating that. Okay, the graph won't be a connected graph. It will be specified as unconnected graph. 7 to 5 తీసుకున్నాను అనుకోండి. Again this particular edge has to be visited, right? So if ఇక్కడ connect చేశాను అనుకోండి, then it will be what? A cyclic graph. So I should remove that particular cyclic graph. So in order to remove that one, I'll be taking that edge between 6 to 5. So I'll be drawing that one as 1, 2, 3, 4, 5, 6 and 7 like this. So 10, next 11, 12, 14, okay, then 20, then here directly I'll be making that vertical edge as 23. Now it is said to be as a connected graph with edges. Okay, so 67 plus 23, I'll be getting that one as 90. So the cost will be 90. Okay, so this is about the cost weightage of finding the minimum cost of a spanning tree by making use of Kruskal's algorithm. So how many steps I got? 1, 2, 3, 4, 5 and 6. Steps that I need to follow in order to find the minimum cost of a spanning tree. Okay, so before finding the first edge, before this one, you need to specify the empty edge. Okay, na? Empty graph. Okay, so first of all, the graph should be specified as an empty with no edges. చూపించాం కదా మనము దానికి ముందు ఫస్ట్ వితౌట్ ఎడ్జెస్ ఐ నీడ్ టు డ్రా వన్ గ్రాఫ్. సో టోటల్ 7 స్టెప్స్. ఏదైనా సరే ఎనీ గ్రాఫ్ యూ కెన్ టేక్ with any number of ways, but you have to specify that first thing that you have to keep in mind in Kruskal's algorithms is that first the graph should be an empty graph. That means it should not have any edges that exist between the each and every vertices. Okay, that is the first condition you have to keep in mind. Coming to the second condition, that you need to find out the minimum cost of n number of vertices. Okay, in entire graph you need to find out what is the minimum cost that exists in the graph between any two different vertices. Okay, then after that one, next you need to find the next minimum graph, minimum cost. Like that, you need to start finding the cost from the smallest element to the largest element. Or okay, so whenever we are specifying this one as a minimum spanning tree, means you need to calculate the cost from minimum to maximum. Okay, then you will be getting the shortest path traversing of that particular graph from source to destination. Okay, so this is the different kind of steps that you need to follow in order to find out the shortest path or minimum cost of that particular spanning tree by making use of Kruskal's algorithm. Okay, so by this our 4th unit is completed and our entire CTPST syllabus is completed. Any doubts in this one, ma'am? Is it clear for you all? Are you here?
Yes, ma'am.
Yes, ma'am.
Yes. Okay.
Yes, ma'am.
Can we have a class for this particular CTPST? We have completed our syllabus, right?
Yes, ma'am.
No sound. Okay, thank you all guys. Okay, so we have completed all this CTPST syllabus. Okay, so if possible, if you are having a class from tomorrow onwards, okay, we'll start doing revision. Okay, so today afternoon from 3:30 onwards, yesterday how I have conducted, at the same time, we'll be having the second mid objective test. So some of them are attempting in forms. Don't attempt, all of you. Visit the team in the teams only. Attempt the test so that the grades will be recorded in the team. Is it clear to everyone? Okay, prepare well. Okay, and all the best, ma'am. Thank you all, guys. Teja, are you here? Teja. Thank you all, ma'am. No one should leave. I'll download the attendance sheet. Just wait. Okay, thank you all, ma'am. You can leave and join in next class. Thank you.